Yeah, let's invite our speakers here. Rob, Tommaso, you get the first choice of seats. Christian, Yone from Nokia, and Jimmy from Ericsson. This is looking good. Looking forward to it.
On this side. Major industry on that side.
And over to you.
Okay, so I think this is going to prove to be a very interesting discussion here, and it relates to some of the presentations we've already heard this morning. So I think at least two of the panelists have already been introduced, so I'll skip Tommaso and Rob. Let me now introduce the other panelists so everybody knows who's here. I'll start with Christian Gallard, who is my countryman from France. So Christian is at Orange, which is one of the major operators in Europe, and he leads research activities in connectivity and wireless broadband services. He also represents Orange on the OAI board, and has recently assumed the role of General Secretary on the OAI board. So, welcome. Oh, okay, all right. Joni Soininen is head of open source and technology vision, and responsible for those areas and initiatives around them at Nokia, among other initiatives. Before this, he had various roles at Nokia Siemens Networks, Renesas, and Broadcom, and has an extensive background in telecommunications and software engineering. He's also a board member of Linux Foundation Networking, and the OAI board member also. And finally, Jimmy Alberg is director of Ericsson's open source program office. And over the last 10 years, he's had various positions related to intellectual property, standards, open source within Ericsson. He's also an OAI board member, and I believe also an Okudu. No, that's not you? Okay. And he's been involved in various activities where open source and open standards increasingly intersect. Okay. So the topic I'd like to address here, well, maybe, no. Where am I going here? I'm sorry. Is essentially the state of Open RAN today, or open source RAN. This is a slide, actually, I showed a couple of months ago at a workshop that was organized by Tommaso in Boston, where I just wanted to make the point that there have been a lot of projects over the last about 12 or 13 years, a bit more than that actually, but 12 or 13 years, I mean, OAI, yes, SRS RAN project, but there are other ones. I mean, GNU Radio has been around for a very long time. That's also open source software, a little bit different than the two that we'll talk about today. Another one, Osmocom also, which was really for 2G and later 3G type networks. All of this was basically the beginning of open source RAN, okay, all of these projects. And they've all come a long way, but the state of it today basically is two Linux Foundation projects governed by the Linux Foundation. So Duranta, which is OAI, and Okudu, which is SRS RAN. Okay, so we see, at least when it comes to 5G and 6G, what is there. There's another important element here, which is NVIDIA Aerial, because that has also been open sourced. It's not 100% open source. There's some elements inside that are binaries, but that's another important piece in this puzzle. And after what we just heard from Tommaso, the Claudes and codexes of this world are just going to eat this stuff up today and be able to generate new things. And that's also one of the questions that I'd like to address in the panel. So basically, I have four concise questions, and maybe we'll go through them one by one. One of them is related to the impact, and we'll start with that one. So in terms of impact on these companies' businesses, but also impact on research, because that's always the concern for a community like this one. I think it's safe to say that open source RAN has moved from lab software to Linux Foundation governed infrastructure, okay, with those two projects, Duranta and Okudu. So for your organizations, do Duranta and Okudu change anything fundamental, or are these still mainly research and integration tools? So maybe I'll start with our two operators. So Rob, do you want to take that one first?
So thank you for inviting me to be part of the panel, and of course enjoying the morning and chatting with old friends, old colleagues, and getting to hear their perspectives overall on where we're going with 6G, with open source, with AI RAN. A lot of really interesting topics, and really good to see Tommaso's presentation and think of, okay, there's now a space for folks who are not as tightly coupled to the commercial development of networks to really have an impact. And we see this already. We organize hackathons inside the company, and then some of you know I also wear a cap as the chair of the Telecommunications Infrastructure Project, and together with AWS at Fuse last fall, we had dentists and biochemists defining orchestration and automation frameworks for cellular networks. This is what happens, is that AI empowers those who didn't have 25 years, I'm sure there's hundreds of years of domain knowledge sitting here in this panel related to radio access networks, now able to start to innovate and create new ideas of how you would orchestrate, automate networks, but also offer differentiating services. So that's really the key, I think, for us. We're a founding member of Okudu. My old team inside of Nokia was very involved, and I was very happy to inherit that team for Laurent. As he left, we didn't get to know each other, unfortunately, when we were there together in Nokia, but inherit the team that was contributing very actively from Bell Labs into OAI. I'm glad to see that it continues between the two efforts to now start to make available opportunities. Many of you may or may not be aware of the fact that the US government is now seeding investment directly in Okudu by asking and issuing an RFP through the National Spectrum Consortium to drive ISAC innovation with an underlying assumption that the stack should be Okudu-based. This is an interesting sort of turn of events. There is a lot of interest in trying to get ISAC available finally to government-based sponsors because they're looking at the cellular network from a completely different perspective than we have for many years as being primarily a communications network as opposed to a sensing network. So we're in a pivotal point where I think research and implementation are actually starting to blur, and that is really being enabled primarily through AI. I will tell you, I still have a very healthy dose of skepticism around Claude Code generating real-time hard code. And I heard Jakob Hoytes, again, a former colleague from Bell Labs, who's at NVIDIA now, and I think he's one of 2 NVIDIA employees in France. He has been actively working on looking at Claude specifically for real-time hard code. So the stack, the physical layer, the scheduler code itself is sort of the last frontier, I'll misuse that word, frontier of where can you go with AI. So just like I will tell you, literally not much longer than a year ago, I listened to Tom Gruber. Does anybody know who Tom Gruber is? He started Siri. I didn't even know Siri was a standalone company, but it was acquired by Apple. He made his dime, and then he left. He gave no apologies for where Siri is today or where Siri is going, and he left early enough that he was before the generative revolution. But he was talking about, literally over a year ago, how AI was not good at math. And I thought to myself, really? AI is not good at math? Well, he meant generative AI. He said, I can give an SAT to generative, and it will generate all the answers and get a perfect score on the English portion. But on the math portion, it would struggle. You could pass the bar exam, but it couldn't fill out your taxes. Well, fast forward a year later now, we have people who are using AI to do their taxes. So I didn't do it. I don't know if you did it or not, but it won't be long, I think, before at least plenty of CPAs are, if they're not already, using it to check their own calculations. But I think we're really in an interesting space where, as the key thing, and I think the impediment, if we roll the clock backwards, OSC didn't have a truly open layer 1, didn't have an open scheduler. These are still considered by many of our vendor partners to be the secret sauce of how they build a base station. It is where they invest the mass amount of their own PhDs. Their engineering talent are primarily focused around layer 1 and around the scheduler. And I think this is the area then, well, now that it's open, gives the opportunity to create that innovation. So we look forward to seeing that kind of innovation now.
Okay, thank you. And Christian?
Hi, everybody. So thank you for the invitation to join as well. So maybe before answering your question, I'm just observing that among the 5 panelists, 4 are part of the board of the OAI Alliance, and 1 is missing. So I would like to, not officially, but at least kindly... It's going to happen at some point. Yeah. So let me invite Rob and AT&T to consider joining, because very interesting discussion, very interesting initiatives we have here. So please join.
How many tokens does it cost?
It's for free. Okay, so now let me also do a kind of a step aside. So just to answer the global question about open source and operators. So on our side, we are quite deeply involved in this open source activity. I will only mention Silva. Probably you all know Silva. So it's a telco cloud layer we are developing, and it's open source. And we want to push it in our networks, actually, in order to avoid having multiple flavors of CAS in order to, let's say, host different applications. And would like to push for a single CAS solution, being able to host RAN, core, and any kind of IT applications in order to make it simpler to operate, orchestrate, and so on. So this first answer just to show that there is interest among operators in open source. Now coming to open source in RAN. So as you know, we are involved in OpenAirInterface since a while, since the very beginning, actually. I'm the oldest board member.
Not by age.
Yeah, thank you for that. I was expecting this from you. Thank you. So what are we doing with OAI? So it's mainly research up to now. But actually, we have put quite a lot. We were talking this morning about IPCI project. So we were involved in one, actually. The objective was, I would say, one of the topic of this project was to develop a sovereign 5G solution, mainly for private 5G, private networks. And we invested quite a lot in that, and thanks to the support of Europe as well, actually, we made it, more or less. It's not completely finalized yet, but showing that we have interest to have a sovereign open source solution in Europe. And then we are also part of a trial together with Airbus and Firecell. So Firecell is also a French company built on top of OpenAirInterface. So it's not, commercial yet, of course, but showing we have interest to test this kind of solution, maybe in kind of trials for the timing, but at least it's a sign that we have interest globally in open source, and more specifically in open source for RAN, mainly again for research activities related to standardization as well, and potentially more commercial, let's say, driven somehow. With probably for macro networks, it's not yet applicable. But for kind of private 5G solution, I think it's a valuable solution.
Okay, thank you. Maybe Yone?
Yes, thank you. And thank you very much for inviting me to the panel. And this is because this is a very interesting panel with a very interesting group of people. And also great to be in the Summer Workshop 2026. I have to say, I don't hope that Jimmy is very upset, but Porto looks a little bit more interesting that she studied that last year, but or let's put it.
Happy to hear that we're moving.
Yeah, or let's put it otherwise. Maybe interesting is not the right word. Much more pleasant. Okay, and the weather is better as well, though that it wasn't too bad last year either. But anyways, looking at open source and telecommunication, especially radio, is that for company like us, we've been using open source for a very long time. It's almost 30 years that we've used open source in different parts of our products. In that sense, open source is nothing new. And it has been basically, lack of better words, the open source has been creeping towards the telecommunication part. It started off with operating systems, first with FreeBSD, then Linux, and so on. And then cloudification actually brought open source into the mindset of telecommunications companies, operators, and vendors alike. And we, through that, and especially I like that Rob had a mention of OPNFV still on the slides and stuff like that. That was something where we as an industry learned to cooperate together with open source. Looking at our telecommunication industry and in the over 100 years that we have been doing telecommunications, of course, this is an industry that has done a lot of cooperation through open standards since the beginning. And so open source is a very natural expansion of that. We know how to cooperate with each other. We know how to cooperate even between competitors or cooperating between vendors and customers and so on. The open source is a natural extension of that, and that is where we are getting now also in the radio part. What has been, we've had cooperation also with of course, with academic circles as well, in both in standards, but also in other academic activities and in research projects and so on. The thing is that basically compared to many other areas, telecommunication and especially radio is very research heavy. So we need to do a lot of, we have to do a lot of research before we get something done in an implementation. Now now with open source implementations of radio, that also allows us to deepen deepen the collaboration also to the implementation, and gives us the possibility of what Tommaso was presenting previously, what universities can do, what they couldn't do with proprietary code, or they couldn't perhaps maybe because they don't have the access to that, or maybe even if they would have the access, it's not made that way that it is as transparent and as easy to collaborate on. So this, I think that this allows a much deeper collaboration between within the industry and with academics, and especially with academic world. And this is a very welcome thing. Also that I think that what is a view of that, or a testament to that this space is also becoming more mature, is the recent start of Duranta, for instance, not only doing localized European research, but really opening it up to the world. Let's hope now that that really also provides fruit in that, and that people come together to work on those. And of course, Okuru coming into the area as well, this opens up new possibilities of doing research in areas what we haven't done before, and also collaboration between these implementations that wasn't necessarily there before.
Thank you. Jimmy, you want to, maybe it's not.
Yeah, so I can try to think of your question again of will this change things or so forth, but I think no, it won't change things, because in a sense it already has changed things. And as Jonna pointed to, we've been using open source for 30 years. or more in this industry, and before that we were heavily reliant on open standards, collaboration, standards collaboration. This is just another sort of area, another mode of that open innovation and that collaboration that needs to happen. And for us, if we're looking at this from a product perspective, it's really, is there a component out there that's able to do what we need? At sort of, if that's available as open source, that's fantastic, then we're going to use that. Is the calculus, could we build this better ourselves? Well, maybe, but the resources we would spend on that, those are better deployed elsewhere, creating value for our customers, rather than us reinventing the wheel just to have a completely proprietary stack. That doesn't make sense for any company, much less so for telco. The unfortunate reality is that the RAN market has been shrinking. As Rob was saying, it's 30 to 35 billion USD today. 5 years ago, that was maybe 45 billion. So that's a shrinking market. Maybe hopefully it flattens out. But that also means that we need to look at open source as part of the supply chain. What can we get out of it? And how do we now position ourselves and the open source community and the open source resources to support what we need from 6G? How do we get the broader open source community, not just the OAI, Okudu, and Duranta, but also other projects to support our needs for 6G? I think that's the really big question for us that we need to figure out, and that goes for this community as well. It's not just the OAI code base. What else needs to exist as open source for it to be really useful, for OAI not to have to build that themselves?
Okay, thanks. And finally, from the university perspective, the passing to Linux Foundation, does it change anything?
I would say, in general, it gives more visibility and potentially a larger base of developers and of researchers. I would say, in general, open source software for RAN is a superpower in many different ways, and it changes the way researchers can do their work in this space. Generative AI is another superpower, and testbeds at scale are a third superpower, and these all compound in a way that is obvious, I think, in the way things are accelerating. And so researchers have an opportunity to be much more relevant to the evolution of wireless and of cellular networks than we were in the 5G era, quite frankly. And that is something that is exciting in many ways. Now, whether that will be a direct commercial impact, it's hard to say from my vantage point. There's a lot of different elements that would have to combine for that, but it's very possible. And I would say, and I don't know that I would bet direct money on that, but I think it's very likely that we'll see some significant commercial deployments based on open source.
Okay, thank you. So that was already an interesting introduction. There are 3 questions left, so we have to speed up here. Second one might go a bit quicker, huh? Because we had a seminal lecture from Tommaso on the subject of AI and code generation. Rob mentioned some work from Jakob Hoytes from NVIDIA. If you listen to a lot of the presentations in the last few months that are coming out of NVIDIA, they're basically saying, this is the new telco engineer. This is the profile of the new telco engineer, which is exclusively using generative AI tools to generate the implementations. I've seen demonstrations even internally with some of our partners at Ericsson, for instance, of tools like that they're using inside their own labs. It's not surprising. But as AI-assisted software engineer now enters telecom, will these open RAN code bases, so today, Okudu, Duranta, become more valuable as shared foundations, or actually less important because the vendors and operators can generate and maintain their own internal software more efficiently because of their existence and the tools that are out there.
Maybe I'll take first stab at that. So I don't know if that's if there is let's put it this way. I'll take a step back. So the thing is that there is a consistent question of what is the role of open source in general in the era of AI. And when you can just generate stuff quickly, why would you need the open source? You can just generate yourself. And that is, of course, not completely true. I'm like, you can generate a lot of yourself. And I think that things like Stack Overflow, those are not getting as much hits anymore as you can actually use. You can ask the ChatGPT or whatever flavor you want to use this week much more efficiently than searching through many answers where you don't know if they are correct. Well, you still don't know if they're correct, but the thing is that it's the same thing as it is with human beings. I think that where we are with AI-generated code is just that it's a tool. We all use it. We all have to use it. You cannot stay in business if you don't use it. It's a little bit like when debuggers came, that you wouldn't do that if you didn't learn how to use a debugger and you tried to read your code on paper still, yeah, you wouldn't stay in business for very long. And when linters came and different other tools that found your errors for you, now the same way is that that if you are not somebody who still uses VI to write your code, you need to use these tools. It doesn't matter which kind of company you are. These are needed, and we internally use them. I know that our competitors use them, and most probably our customers use them in different things. The thing is that, however, they are tools. They sometimes work for one thing better than they work for other things, and we have to learn to use them, and we have to learn to use them correctly. Now, what that has to do with open source is that we see that now everywhere already, that we start to get contributions from AI to open source. We start to get automatic contributions from AI. We get bug fixes and bug reports from AI. We need to learn how to use this as well, and we need to learn what is actually that we're going to get into our code base, what not. But I'm sure that in future open source, there will be a lot of AI generated code. But like I said, these are not mutually exclusive. It's not like you will generate the Linux kernel in one go through Claude Code or something like that. It is more efficient to use the code that is already generated, that is generated by humans and AI alike, the Linux kernel. And it makes sense that to still do cooperative software development. The thing is basically the software is not, open source software is not just software that you can use. It is also a layer of compatibility. It is a kind of standards through code, and being compatible with the rest of the world comes through that you use something like that. So generating Kubernetes from scratch by yourself doesn't really give you compatibility necessarily with Kubernetes. It's easier for you to download it and use it, but developing Kubernetes will happen more and more with AI-assisted tools and AI-generated code as well.
So to chime in on that, I think what AI so far can't really replace is the industry alignment part of both open source and standards. And that comes to the compatibility part, yes, but it's also how do we ensure that we align the industry around a certain direction, certain technical choices, right? So that we don't have to rehash those arguments every time we regenerate the code. using AI. And as my colleague from Nokia rightly pointed to, AI is just a tool. But in the same vein, open source is just a tool. For me, it's a tool to create industry alignment, to create compatibility, to reduce the cost of creating these components and share that burden among more, or that responsibility among more actors in the ecosystem. And if everyone goes back to, well, we're going to roll our own with using AI instead of engineers, then we're back to that point where we don't have compatibility, we don't have industry alignment, and we have to argue these things over and over in each iteration of that code that is generated. Then there's great arguments for sort of maintainability, scalability, and all sorts of other sort of interesting legal questions that comes with AI-generated code, in the sense of, well, this is not copyrightable, at least not in most jurisdictions. So, like, if you include this in your open source projects, that will have certain implications, at least sort of if you need to reach a critical mass of AI-generated code, there's likely no copyright left in these projects that you can enforce. So what about the licenses and so forth? But those are sort of broader questions, I think, for how AI is impacting the broader open source ecosystem.
Thanks. Who's next?
I can go real quick. I think, as of today, everything that I discussed earlier in Genesis is uniquely enabled by open source software, and it's really, by and large, not possible without open source software. The run software, Kubernetes, the databases that we've used, everything is open source. Now, with the, and that is, that is what enables building a system like that in a matter of weeks to months, right? If you start from scratch, I don't think that there's any way that you can do anything like that. Now, where this goes in the medium term, a couple of years, 3 years, are we still going to be able to distinguish specific open source projects, or will they all be conflated into a big blurb of software that is generated? I don't know. I don't want to make predictions there, but things are evolving fast. As of today, if you take a snapshot as of today, there's absolutely no way that you can do that you can accelerate research in this space without open source projects.
And just one other comment, and we haven't talked much about it this morning, or I haven't heard much, although I think maybe the flavor was starting to appear a little bit in Tommaso's talk this morning. The bigger question, the bigger problem we have to deal with often when we want to bring innovators in to create and benefit from the investments overall in 5G and what's coming in 6G is you need access to data, data from the network itself. And where does that data come from today? Operators are notoriously protective, especially of RAN data, because it often covers, or it has privacy and security information from users, or it has specialized enrichment that they've done themselves and aren't necessarily open to the idea of sharing data directly from their network. So the question is, if you're trying to build a large-scale model of network behavior, how do you start? How do you train it? What do you train it on? And then if the model is initially seeded on a particular operator's data, will that operator agree to ultimately releasing that model and that data? The answer, at least that I see so far, is no. Mm-hmm. I see some openness. Our European partner, Telefonica, agreed in the Telco Foundation infrastructure project, in TIP, Telco AI infrastructure project, foundation project, to release the data for the transport, because it doesn't have a lot of enrichment, it doesn't have subscriber-specific data, and the schemas, the FCAPs are all open. But the RAN side, it's still very much closed. So we see a lot of resistance. I see it, and I'm front line of trying to figure out how do I even enable our partners to continue to evolve. We are working closely with Ericsson on this project at the moment of saying how do we share the data. And there's a variety of different positions from operators, but what looks enticing as an opportunity is build a large-scale model based on an open source reference, train the model on open source, then take the model back into an operator's network, and then make a decision. Do you continue to use that model and RAG or FRAG or whatever you need to modify it without actually touching it, or do you need to actually enrich and change the models? And that's an exciting thing as an opportunity to say, how do we seed these models that then can be used in the network? We know in many cases for physical layer innovation, it's possible to train a model just with the PHY data. But if you get into a scheduler use case, a call admission control use case, an intent-driven use case, you need far more data to train, in which case, where is the data coming from, and how will you build it? So this is really, I think, what we can see is the benefit. And I think, to agree, what NVIDIA is pitching a little bit with their vision of, yes, if we open the PHY, we open these layers, and then some people go out advantageously and leverage that, whether it's through OpenAI or others that are building open source projects, there is an opportunity to create the data that's needed in order to develop the new algorithms and allow to break those barriers for innovation.
Thank you.
Maybe just a very quick reaction to what you were just saying, Jimmy, about maybe the cost reduction using AI in order to generate code. So on this, actually, I'm not fully convinced. And globally, I think we have to really understand the sometimes hidden costs coming with the artificial intelligence. So probably still engineers with very good skills could still probably do the job. So we have also to take into account the, the overall cost, including the power consumption and so on. So it's really needed in order to, before saying or stating that artificial intelligence will replace all these very skilled developers.
Okay. So in the interest of time, for the moment, I think I'm going to skip question C because to a fairly large extent, Yone and Jimmy kind of answered the question. It was really about standards versus running code. So we even heard the words standards through code from Yone. So I'll skip that question, and maybe if there's a couple of minutes at the end, we can address it. But I think I don't really usually like talking about licensing and IPR, but we have Jimmy here. In a field that's shaped by standard essential patents, okay, we make a big deal about this with OAI, in OAI. Do you still think that explicit 3GPP FRAND-aware licensing remains important, or will permissive licensing and Linux Foundation governance matter more for adoption?
So like this, and full disclosure, I'm a lawyer, so I'm naturally risk averse. So I enjoy clarity where I can find it, which is one of the reasons why I think that 3GPP aligned and FRAND aligned licensing is the way to go, because it does create a clarity like on how can we use this, what can we expect, and what can the ecosystem expect from this. And one such example is today, before coming down to the stage, I got an email, hey, we found this OpenAirInterface code, seems really interesting, can we use that in one of our research projects? And I mean, that's a very easy question to answer when you have a very clear license that sort of lays out the boundaries. I think to address the elephant in the room, the other project the Okuda project has chosen a different approach to their license. It's not as clear as to the standard essential patents. And to some degree, since it is ambiguous, it's a little bit, well, you make your risk assumption, you figure out sort of if this is good enough for you. But I think there's clear benefits of having the clarity that a FRAND-aligned policy makes. We're not going away from standardization. We're not moving away from 3GPP anytime soon, at least. And in that framework and in that industry logic, with how that's been working with standard essential patents as sort of a way to get a fair return on the investment made into standardization, I'm not seeing that that's that industry logic is changing by these projects. I do think clarity is still needed. Still think that's a very valid approach. Other projects has taken other approaches, but let's see how that pans out.
Okay. Anybody else want to comment? No? Okay.
So actually, I fully second what Jimmy was saying. As operators, let's imagine we may deploy RAN solution based on open source. I mean, at the end of the day, the operators are paying for all these IPR and so on. This is somehow hidden when you are purchasing equipment from vendors. But in case you would deploy open source solution, then you have to have a clear view on what are the real costs implemented in, I mean, the patents and so on implemented in the software. So if you avoid, I mean, solving this stuff in a license, then it will become really a burden. So again, for sake of clarity, I think it's better to use a 3GPP line, friend line license in order to make things clear for each and every player.
Maybe a slightly different point of view or perspective. I think to some degree operators benefit from the FRAND and the aggressive marketing and sales of IPR from our infrastructure partners, because it finances and it supports the R&D quite extensively. So if you were to look at financial statements from Ericsson or Nokia over the last few years, you'll find out that a significant portion of their EBITDA comes from the sale of IPR, not to us, not to the operators, but to other parties, to automotive, to healthcare, to adjacencies, to device makers. And this has been the mainstay of the business for the last 15 to 20 years. And it differentiates perhaps some of the companies that are no longer with us on the infrastructure side compared to those that are with us today, that the amount of money generated in IPR licensing is significant. It means that this is an industry that we can't easily disrupt or change without having a direct impact on where we go. So it's important that whatever framework gets put in place ultimately allows for the industry to continue to make money on IPR and continue to have an ability to license that in a fair and reasonable fashion. We always run into challenges where, unfortunately, there are plenty of people out there that are not fair and not reasonable. So that does create challenges for us, because they don't typically sue the vendors. They sue the operators. And why? Because we use it. And so in the end, we face this challenge often, that we are in a situation where we need help from our vendors to secure this. So there needs to be cooperation. There needs to be an understanding of how do we balance these rather precarious and difficult conversations of saying, how do you make it available? How do you make the opportunities available? Because I think to some degree we benefit from it. We pay for effectively lower cost gear through this, but then there's a flip side of it. There is risk associated with it. And sometimes, believe it or not, even though we're indemnified, we still end up paying.
Just to chime on, people are not always fair and reasonable, and as a lawyer I'm very happy about that, because it means job security, right?
Yeah, and maybe I'll add to that what Rob said, and I think that that's a special thing in not only in telecommunication, but especially in radio, that the R&D cycles are very long, and especially the research phase is very long. When you start 3GPP standardization, there's almost 10 years of work already that has happened before that. And then there is this very early investment into the technology that is significant, which then also generates those patents. So it is a very particular industry, and it works in a particular way, where there is a very early investment without any knowledge yet that is there a return of the investment or so on. And therefore this approach works very well in this. The risk would be that if there wouldn't be this approach, would be that people would actually hide their innovation and not make them public. And that is basically what was the idea of patenting in the first place, is that you get something for that you make it public, and that has allowed the standardization to happen in the way that it has. So I still believe that these are important. It's good. And like Jimmy said, that there is also very important that you know what you get. And one thing that I wanted to say, still comment on what Rob said, that there are these people that are not necessarily fair and reason, and who are not fair, neither fair nor reasonable, and they go after our clients, which is very unreasonable from my point of view. But these people could basically, regardless what is the IPR regime, they could do it because they are outside of the system. And that is the thing as well, that we have to understand that the players outside of the system, they can always attack the system with their own approach.
Okay. So how much time do we have left here, Fon?
2 minutes.
So maybe we can open the floor to the audience. If there's any comments on, I could also ask the audience some questions here, but does anybody want to comment? Oh, okay.
I have a big one, but let's see. Should I introduce myself?
Sure,
or,
go ahead.
Stefan from Open Radio Systems, small startup, also professor in Germany, and I was with Bell Labs before under Todd Seiser. Hi Rob, we didn't meet back then, but I know you were still back then with Bell Labs. Okay, my main issue is how do we bring open source runs into public networks? So the impact. How do we bring global impact, carrier grade focus? That is also what you had, Raymond, on your first slide. So how do we strengthen that? US is clearly betting on it. They have tried with OpenRAN before. Now they're trying again with substantial investments by the US government, led by Tom Rondeau, National Spectrum Consortium. Rob, you mentioned it, with Okudo into open source. It's logical for them because they get their foot back into the mobile network infrastructure market. They have left when Lucent was acquired by Alcatel. And I hope that they will have some impact with that because it shakes down maybe even the European solidified market a little bit. So my problem is when I'm pitching open source runs to operators and investors, they usually don't like it because openness leads to flexibility and flexibility leads to confusion. So they're usually confused. They watch it, they look at it, they love it, and then they buy from Ericsson or Nokia. Because eventually that's the safe bet, right? And for them it's a logical choice. Basically, I learned when an MNO can choose between vendor login and confusion, they choose the vendor login. So how do we get out of this? That's mainly my question. I think still, I mean, I'm not meaning about breaking the monopoly of the vendors. I think they still have a role as platform providers, maybe. So they may keep the physical layer for themselves, but then start on top of this. But will it be killer features that open source can offer for carrier grade runs, like ISAC was mentioned before? Better uplink performance was mentioned. NTN, non-terrestrial network, may be a killer feature. Will open source projects become the cheap production line of established vendors? That was also mentioned of Jimmy in nicer terms. Or will Nokia and Ericsson move to open source, keeping the lower parts of their platform for themselves? What do you think about this? Or will a new industry develop, like a new RAN integrators, but for public networks, not for the small private networks, like we already have that to some extent? So what do you think? What can we do to bring open source RANs into the public networks? So to bridge this big gap. Sorry for the long speech, but it's a complex ecosystem.
Who do we start with? Let's start with the experts from the industry side on that.
So just a quick comment, and good to see you again. And yeah, remember us well from the time in Bell Labs and Todd and all. I think I kind of hinted at it a little earlier that new compute platforms and making new compute platforms available is a challenge for the incumbent operators. So similarly, flexibility leads to confusion on their side. So if we tell them we want GPUs, ARM, AMD, Intel, plus purpose-built, 5 different platforms they have to do, they can't invest in all 5 platforms. So the question is how do you advance AMD? How do you advance ARM? And how do you advance it in a uniform way, as opposed to one vendor takes a bet in NVIDIA, one vendor takes a bet on AMD, one vendor takes a bet on Intel? How do we get to uniform answers? So open source gives that opportunity to level set specifically on that. Do I think it's going to reach public networks anytime soon? I'm not so optimistic about that. I think it will take time, but just like it took for Linux, it took for other Unix-type open source efforts, you have to be careful not to overuse the analogies to Linux, because an OS and a stack are quite different in terms of the behavior. And we're also looking for a lot of outside-in innovation that is requiring domain knowledge that links to the underlying application, which is radio. So if that is the case, then you can't necessarily say it will be following the same kind of trajectory that we saw where proprietary forms of Unix just died on the vine. And then finally it said, okay, the only thing that was going to survive, because there was so much churn in the underlying platforms, was finally Linux. So I think there's opportunity. It is coming. There's investment, I think co-investment. I think in the end, a lot of the startups will benefit from this. A lot of academics will benefit from this. Ultimately, those who want to see early proofs of concept on more targeted applications, like government entities on ISAC, will benefit from this. But will consumers benefit from this? It may be a while.
Can maybe add something, and again, from somebody obviously who has nothing to do with how operators manage their business and make money, but one tension that exists today, right, is the fact that the revenue of operators is worldwide in general not going up, right, and it seems to have hit the ceiling in many different ways. There's a big opportunity for monetizing, I would say, what is unique about operators, and that is, they have a presence on the territory. They have antennas, radios, radio sites that have been managing for a long time on the entire territory. These radios, these sites, I would say, can be used to provide new services. Sensing as a service, inference as a service. And being able to do that requires a certain degree of openness, right? And of opening up functionalities to as a platform that you can build applications on top of, right? Now, obviously, there's many different ways that this can happen, right? This can happen in a very, closed proprietary form, right, from a technology point of view, or it can happen in the form of creating programmable platforms that create a marketplace for sensing and inference applications that can be brought to the edge, right, and also at the same time a lot of monetizing the data from the physical world, right, that will be the basis, many say, of world models that can think, reason, and act about the physical world. That will require data that comes from the physical world and from something that is distributed on the territory, right? And I think that if operators are going to be able to leverage a lot of these opportunities, that will come from a certain additional degree of openness. I'm not 100% sure in what form it will come, but that's sort of the direction in many ways.
Yeah, maybe I'll add it to this as well from a vendor perspective. I think that I think Rob is right. We shouldn't do. We have to be careful of doing doing too strict parallels with a different kind of software. So With the Linux kernel, these was basically a thing that where there was a lot of domain knowledge, very large industry that was interested in that, and there was the community and the potential of the community was very big. The same thing with cloud. When we come to telecommunication, that is already a smaller industry. When we come to radio, that is a very small group of people in the world. So you don't, that domain knowledge is with people that usually are studying for their PhD or have their PhDs already. So it is basically, it is a little bit different thing than the access to the theory of operating systems, which was needed for Linux at the time. That's sad. It doesn't mean that there wouldn't be open source in the kind of like in the public networks. I'm like, there's open source already now, not the radio part. The thing is also what we have to look at then on these implementations like OpenAirInterface or Okudu, what they are aiming at. So they are clearly aiming at more on the small cell implementation. They are not really at the macro cell implementation. So the thing is also that depends on what part of the network and in which public network and how. The other thing is also that I don't see, and Rob might, and the others might disagree with me, but I don't see that operators would download software from the internet and install it on base stations and run their network off that. That's the same way as they don't generally do with, they don't download the Linux kernel and everything else that is needed to build their own distributions. Sometimes they do, sometimes they don't, depends on the operator, of course. But the thing is basically that open source software is not a product. Open source software is something that is usually collaboratively generated software that you can use to productize. And that is then the question is then who productizes that. So in a way that looking at will there be open source or not, maybe that's not the question. That comes to business models, that comes to then the community and so on. It is the question what we can do with the software that is available today, what we can do with OAI, what we can do with Okudu, and what new things we can build with this.
Yeah. To chime on a little bit, and yeah, not in the radio, but if we look at sort of the scale of Ericsson, last year we brought in 72,000 new open source components into our product development. This year we've averaged 40,000 new open source components each month so far. So there's definitely open source in our products, in the radio access network in a wider sense, but maybe not that much in the radio. I don't know our software bill of material for those parts specifically. So it's definitely there. Another way, and maybe this is far out there now, but another way that we're going to see open source in the RAN and in the radio is that, you know, we're all going to be using AI in one way or another, as long as it's cost effective, to improve on the software, to improve on the models. That software will, or that AI will have been trained on something, and that will for sure include the open source software that is available. So in a roundabout way, yeah, AI will definitely make its way into even the RAN, or rather, open source will make its way into the RAN via AI, if nothing else.
Maybe something we have not that much discussed today is about security. So why I'm talking about security, because actually we are, as Orange in France, we are testing different flavors of Cloud RAN from different vendors. And we are deploying, as we are deploying traditional RAN, meaning we are deploying servers in radio sites. And we've got some issues with our security national agency, and it will be time to close. So we have some troubles because actually our national security agency is saying to us that servers are very well-known hardware equipment, and it's the reason which it's quite easy to attack for hackers. And then, in these distributed sites, I wouldn't say it's open, fully open, but it's accessible, physically accessible. So anybody could connect to a server on which we are deploying Cloud Run, and then starting from there could maybe reach our core network and doing something very bad for our network. And then when it comes to open source, we could also say that if we are deploying open source RAN on servers, then the code is known by everybody. And then it would, let's say, increase the potential surface for attacks. So probably it's a mindset that we would have to change as well in order to convince, I don't know, everybody, by the way, that deploying open source would also be a way, to be maybe better protected, because we know the software, we know the surface of attacks, and then we could protect ourselves somehow. So probably it's a mindset to change as well. And as I mentioned earlier, probably in macro networks for the time being, open source, we are not yet there. And that's why we were, on our side, starting with a private 5G, for which we do not have the same level of, let's say, expected performance, expected, reliability, and so on. So that's why it could be a way to introduce open source before going to those macro type of sites.
Maybe just give me 2 seconds to address this, maybe from a slightly different angle, more a researcher or innovation type angle. To a certain extent, this is already happening from the perspective of innovation transfer. So smaller entities or universities that are developing innovation, injecting it into something like OpenAirInterface, where you can explicitly contribute. And there are several in this community. That's a little different in Okudo. That doesn't exist in Okudo. You heard it from Jimmy. If the code is good enough and serves their purposes, they will take it. It's cheaper for them to do so. But the innovation itself is going into the open source, and that it's very difficult to measure, how that gets into the commercial implementations. But that is the right avenue, in particular, for smaller companies and researchers that are working in EU projects, that are working in US public-funded projects, that are working in direct industry contracts. This is a common language with these guys here. You inject code in there, they understand that too, and how it could effectively improve their own businesses, even if they don't necessarily take the code as is. But it is a piece of language, and if you are fortunate enough to actually have a deal with one of them, it could be actually lucrative for your organization. And I think that's the right way to look at this, rather than taking the code and nuking the existing networks and replacing it with a new code base.
Rather than open RAN.
Depends what you mean by open RAN. Huh? Okay. Okay, so thank you everybody. It was very interesting.